Students, welcome to s.mathguru classes. Now our main discussion is total differentiation about partial fraction. Total differentiation we using some chain rule, some derivatives, how to solve some problems. Now last video it was given the formula. Next we consider some problems. The problems is that if z equal to f of x comma y, where x equal to e to the power u cos v and y equal to e to the power u sin v, show that y del z del u plus x del z del v equal to e to the power twice u del z del y. And number 2 given del z del x whole square del z del y whole square equal to e to the power minus twice u del z del u whole square del z del v whole square. Now we have to prove this. Solution step. So first we find del z del u. Del z, so here given, okay, del z del u, del z del x, del x del u, del z del y, del y del u. Using chain rule we get this in total differentiation. So this implies del z del u equal to del z del z del x del u x means e to the power u cos v, del z del y del u y means e to the power u sin v. We get this one. This implies del z del u equal to del z del x, and we differentiate partially with respect to u, and this is constant. So d du of e to the power u cos v remains same, and del z del y we differentiate with respect to u, then e to the power u sin v. We get this one. Or we can write del z del u equal to e to the power u cos v, or e to the power u cos v means we can write this one, e to the power a u cos v. E to the power u cos v means we write x del z del x plus this is y del z del y. But in our problem del z del u is multiplying by y, so we multiplying both sides by y. Now y del z del u x y del z del x y square del z del y. If we multiplying both sides by y, because we have y del z del u, so we multiplying by y, we get this one. This is number 1 we consider. Now again first we find del z del u, next we have to find del z del v. Again del z del v, this equal to del z del x del v del z del y del v. So using chain rule we get this one. This implies del z del v del z del x del v x X means e to the power u cos v. E to the power u cos v. Del z, del y, del v, y. Y means e to the power u sin v. We get this. Now this implies del z, del x, we differentiate with respect to v, that means e to the power u is constant. E to the power u, d dx of cos means minus sin. So d dv of del v of cos v means minus sin v. So this is minus sin v. Del z, del y, and we differentiate with respect to v partially. So this will be e to the power u cos v. We get this. Now this will be del z, del x. This value e to the power u sin v means y. This is y. So this is minus y, and del z, del y, this one x, e to the power u cos v means x. So this is our del z, del v. Now in our answer, del z, del v multiplying by x. So we multiplying both sides by x. If we multiplying both sides by x, then we get x del z, del v minus xy, this y becomes front side, del z, del x plus x square del z, del y. We get, this is number 2 we get. So this and this we get. But in our answer, y del z del u, x del z del v. Just we adding these two. This and this adding, we get y del z del u, x del z del v. This one we get. Now adding 1 and 2. Now 1 plus 2 implies, if we adding 1 and 2, so in 1 left hand side is y del z del u, and 2 this is x del z del v, and 1 right hand side is xy del z del x, y square del z del y minus xy del z del x plus x square del z del y. We get this one. Now these two are cancelled, this will be like terms, and from these two taking del z del y common, then we get x square plus y square del z del y common. But in our answer, e to the power twice u given, del z del y given, but answer given e to the power twice u. So we remove this x square y square. If we remove x square y square, then what we get? The value of x is this one, e to the power u cos v, and y means e to the power u sin v. Just putting this value x and y, because in your answer x, y are removed. Free from, this term is free from xy, so independent of xy, so we remove xy, putting the values of x and y, we get this, and this is del z del y, and this will be e to the power twice u cos square v, e to the power twice u sin square v del z del y, and e to the power twice u common, we get cos square v plus sin square v del z del y. So e to the power twice u cos square v sin square v means 1 del z del y. Therefore what we get, y del z del u x del z del v equal to e to the power twice u del z del y. This is the first proof. We get this one. Y del z del u x del z del v equal to e to the power twice u del z del y. This is the proof. Short. First one done. Next you have to find second one. Next we want to prove the second one. So number 2 you want to prove. First one is over. So first we find del z del u. Del z del u, this is del z del x del u del z del y del u. By using chain rule we get this one. Del z del u del z del x, and x means we know this, del u, x means e to the power u cos v, and we differentiate partially with respect to u, then this is variable, this one constant. So this will be z del x e to the power u cos v. We get this one. Now this is del z del u. We divide both sides by e to the power u. Then if we divide by or multiplying both sides e to the power minus u, e to the power minus, because our answer given minus u, so we multiplying both sides by e to the power minus u, then we get del z del u, this will be cancelled, we get cos v del z del x. We get this one. Suppose this is number 3 we consider. Again we find in our answer del z del u, del z del v given. Again we find del z del v. Del z del v equal to del z del x del v del z del y del v. We get this. And this is del z del x, x means this one, del v, x means e to the power u cos v, del z del y del v y e to the power u sin v. We get this. And this is del z del x, this is with respect to v means this one variable, this one constant, e to the power u constant, del v of cos v minus sin v. So minus we write down here, minus e to the power u sin v. And this is del z del y, and we differentiate partially with respect to v, then this will be e to the power u remains same, this will be cos v. We get this one, del z del v. Again you multiplying both sides by e to the power minus u, then del z del v minus sin v del z del x cos v del z del y. This is number 4 we consider. So we get this, but in our answer we get e to the power minus twice u and this whole square we get. So if we squaring this and adding, now 3 square plus 4 square implies, we adding, squaring and adding. If we squaring this one, we get e to the power minus u del z del u whole square, and in left hand side of 4, then this one e to the power minus u del z del v whole square, and on right hand side we get this one. So one thing is left, this one I left this one. I rewriting this del u y means e to the power u sin v, this one, and this is del z del y e to the power u sin v, and this will be e to the power u cancel sin v del z del y. This is number 3. One thing is left. Now we squaring this and this and adding, and here also is squaring. This will be cos v del z del x plus sin v del z del y whole square plus this one also, and this is minus, this one plus. We write the plus sign is first. Cos v del z del y minus sin v del z del x whole square. Just adding, squaring and adding this one and this one and this.
17 minutes का about to be used.
Huh?
17 minutes.
আগতটো আছে, এটা হ'ব নো প্ৰবলেম তেনেহ'লে, এটা প্ৰবলেম সলভ কৰা হ'ব। Now let us consider another problem. W equal to f of xy and x equal to r cos theta, y equal to r sin theta. Show that del w del r whole square 1 by r square del w del theta whole square del f del x del f del y whole square. This equal to this you have to show. Now solution is start. So del w del r we can write so here given x equal to r cos theta and y equal to r sin theta. So first you have to find del w del r. This equal to del w del x del r, del w del y del r. We can express in chain rule. We can write this. Then del w del x del r x means r cos theta, and del w del y, this del r y means r sin theta. We get this. So this equal to del w del x, and this is cos theta, del r 1 cos theta, and del w del y, and this is sin theta 1 sin theta. So what we get, del w del r equal to cos theta del w del x plus del w sin theta del w del y, or w we can write f also. This is del w del r, this is cos theta, that w means f, we can write f del x del f del x sin theta del f del y. We can write this. This is number 1 we consider. So we get del w del r. Next you have to find del w del theta. Again del w del theta. This is del w del x del theta. Del w del y del theta. This is del w del x del theta x. X means r cos theta. R cos theta. Del w del y del theta y. Y means r sin theta. We get this. And this is f. W means f. Because our answer given f del f del x, this will be r. D dx of cos means minus sin. So this is minus sin theta. And this one del f del y r cos theta. We get this r cos theta. This is del w del theta. We dividing both sides by r. This implies 1 by r del w del theta equal to minus sin theta del f del x plus cos theta del f del y. This is number 2 we consider. But in our answer del w del r whole square given, this whole square given. So squaring these two and adding. Now 1 square plus 2 square implies. Now we write this 1 square means 1 is del w del r del r whole square and plus this whole square 1 by r del w del theta whole square, and on right hand side of 1 this is cos theta del f del x sin theta del f del y whole square plus this one minus sin theta del f del x cos theta del f del y whole square. This one we get. So we write here from here this is del w del r whole square and this is 1 by r square del w del theta whole square, and this is a plus b whole square. This is the first formula in our life. This will be a square cos square theta del f del x whole square plus twice ab 2 cos theta sin theta del f del x del f del y plus sin square theta del f del y whole square. This is a plus b whole square. Finish. Next this is a minus b whole square, and this will be sin theta del f del y whole square minus 2 sin theta cos theta del f del x del f del y, and this will be cos square theta del f del y whole square. We get this one, and these two are like terms. This will be cancelled, and from these two we write directly we write sin square theta this whole square, and from these two cos del f del x and del f del x, this one, this is x, x. From these two, del f del x common we consider, then we get cos square theta plus sin square theta del f del x whole square, and from these two, del f del y whole square common, sin square theta plus cos square theta del f del y whole square, and this is 1, this is 1. Ultimately we get 1 del f del x whole square 1 del f del y whole square. Therefore finally we get del w del r whole square 1 by r square del w del theta whole square. This is del f del x whole square del f del y whole square. This is our proof. Very nice solution, very easy. This is nothing, very easy, very simple. So dear students, these are very these are very easy and very simple. This is the complete proof of the given problem. So these are very nice, very simple, very interesting. Just practice. Mathematics main medicine is practice. With practice we can easily solve. Without practice these are very difficult. So these are most important for B.Tech course, B.Tech engineering course, and B.Sc major also in mathematics major. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.